there, I'm Hugo from TechCornerTV, and today I will continue my oscilloscope saga with a new review. That's right, I have here sent by Loto Instruments for review the OSCA02X. If you don't know Loto Instruments, let me tell you they are manufacturers of modular USB oscilloscopes. It's a very interesting concept because you expand your oscilloscope with different modules that can be bought with the oscilloscope or individually at a later time. The expansion interface is open source, so anyone can develop expansion modules. The model that I have here has a bandwidth of 35 MHz, although Loto Instruments has models up to 100 MHz, and it is delivered with a function generator and a 8-channel logic analyzer. But let's not waste any more time and allow me to show you all the features and what's in the box. Let's jump into it. I have here the oscilloscope for opening. With the box it came this envelope that has a letter from Loto Instruments, a thank you letter by using their products. It's just marketing, but it's a nice touch. Yeah, you have here the email contact. So yeah, so it seems okay. We also have in here, okay, let me take this out. This is the OSCA02X oscilloscope. The X defines what comes with the oscilloscope. This is a modular oscilloscope, so the X means that you have a logical analyzer and a function generator. We have here the channel A and channel B. We have the output for the logic analyzer and other probes that you can use it, other modules. Also in here you have the connection for the function generator. It has these bands, these rubber bands around it. It's pretty cool because it will not allow you to slide on the bench. And yeah, on the back side you have, I think this is the reset button, you have the normal USB connection to the PC and the power and the status LED. Yeah, that's it. Let's see what else we have in here. Okay, now, in this box, let me take everything out. We have the normal probes. This is the 16100 probes. Not sure, but I believe they are 300 volts or something like that. 10 times. Yeah, they go up to 200 megahertz. And I think they are cut to, yeah, rated 1 time 150 volts, 10 times 300 volts. Pretty standard. Let me take this out of the way. So we have also packed with the oscilloscope BNC to crocodile tweezers. Cable, also a USB cable, type 2 to type A to type B, to connect to the PC. We have the quality assurance, yeah, and we have here the cable with the grabbers for 8-channel logic analyzer. These are, well, shape grabbers, they are losing the caps. You have the D15 socket to connect in here. And yeah, and last we have also the function generator. This is a 13 megahertz sine wave function generator. It can go up to 8 megahertz in triangle wave, and in square wave you can go up to 1 megahertz. It's a modular design, as I told you before. We connect it here, and we have the buttons also. Let me put the buttons first. Okay, and this one also. Yeah, with the amplitude and offset. We have 2 channels, and as before we connect here. This is the module S02. Okay, well, right now I will open this and see what's inside. Okay, I have here the oscilloscope already open. The board seems okay. It has here two points to notice. These jumper cables that connect to the function generator are glued with silicone or something like that. It's not the polish end that this oscilloscope deserves, but yeah, it's what it is. We have here glue, so we can not, the cables will not disconnect. In terms of ICs, we have here the Altera Max 2. It's the logic of the oscilloscope, the logic unit. We have here a 64K memory RAM and also a EEPROM here with 64K also. This is the isolation, the current isolation component. We have here 2 relays. In here we have the MXT 2088. It's the ADC 2 channels, 100 millisamples per second. And in here we have the controller for the USB, a crystal oscillator. And yeah, it's pretty much what we have here. Well, this part, it's a little weird. We have here a D25 female and male connector to connect those 2 boards. Well, in this oscilloscope has 2 shells. The one I have here is the one that is more robust, it's metallic, but there is a one that is in plastic, and that one has this part of the board. It's mobile, you can turn it, so it has a mobile connector here. So they use the same board for this and use this hack to connect both boards. You can see here that this board was made on July 13, 1 year ago. It's the version 3.0, and yeah, it seems okay. The structure doesn't seem nothing bad here other than these 2 connectors. Yeah, it's simple. 35 megahertz. Okay, I will now close this and let's do some tests. I have here the oscilloscope ready for the review. The first thing we do when we have an oscilloscope, a new oscilloscope, is to calibrate the probes. As you can see, we don't have the square wave output, the connector for calibration, but don't worry, there is a small trick to it. Just take the tip off the probe and connect the probe to this hole here in the socket, in the DB15 socket, and connect your probe to the oscilloscope. After that, you will do the normal. Let me just show you. Okay, we have here the software. To calibrate the probe, you just need to start the device here on the bottom. Go to the frequency generator, setting the pulse width modulation. Start the pulse width modulation and do a auto. Okay, now that we have here our square wave, the probe is well, almost set. You have just do a small adjustment. It doesn't seem to. I think this key is already messed up, and okay, the key that I have here is already not in perfect conditions, and we just calibrated our probe. So now we just close the PWM pulse generator, and let me show you what's on the screen. To show the oscilloscope working, I will use my function generator, my 2 channels function generator. Let me connect it. Okay, first one and second channel also. Let's set up 2 square waves. Let's do auto. And here we have 2 sine waves, and they seem pretty good. Okay, so we have the signals here. Let me start by saying that for a PC software, this is pretty good compared with normally exists. Even my Rigel has a very bad software. Okay, it's a bench oscilloscope, but even so, the software it's nonsense. This one, it looks like they thought a bit about it. It is filled with functions and features, and yeah, it's quite nice to work with. So on the right, you have here the vertical column with the voltage, the vertical division, the amplitude. We have here on the bottom the horizontal divisions for the timestamp. In the bottom, we have a small column, a small line that has the channels, and it has the auto measurement. It's always measuring and giving you the results for the main values, like rise time, peak to peak, everything else. And here you have if the channel is working in DC or AC. If you change it here, it will change on the bottom. On your right, you have this column with several icons. I will just do a quick go through each one, but I will explain later some of the functions. Well, this one I can explain now. It's a zoom. You can go here and zoom whatever you want to better analyze the signal. Then you have, well, this is only to open and close this right column. You have also the cursors. You have several cursors that you can use. For example, like this and like this, and you have the deltas for each one, and for example, from D to E, from C to D, you have several deltas that you can have. Also horizontal cursors in here with the deltas informing the difference. Other than the cursors, we have the X only zoom. You press here and you can zoom only the X, or this means only the time. To go back, you just press here and it's again in the same. We have here the fast Fourier transformation, FFT, the math functions, and these ones I will leave to the end of this video. We can save as text the waveform or as picture, a BMP or JPEG. We can change the color mode. I prefer the dark mode, it's less aggressive. And we can also take the grid out of the screen. We have here also a measurement tool. You can measure something like this. And in the end, we have the function for the mouse wheel. If you notice the time, I'm gonna move my mouse wheel. On the right, you have in here, you have you can see the time moving. This is done with the mouse wheel. I'm gonna change now. Press once. It changed to channel A, and if you notice here, I'm gonna move my mouse wheel. It will change the amplitude of channel 1 and of channel B, or second channel B. Okay, time again, and it will change the time set. In the bottom, you have here the stop device and start device. When you start working, even if it is connected to USB, you have always to do a start device. In this screen, you can take it out of the screen. It's the history or the buffer, the memory of the oscilloscope, but you can only navigate when the device is stopped. Okay, you can go through all the memory. Let me take that out of the way. Yeah, the measurements. Yeah. You can navigate this, but only when it's stopped. It doesn't make much sense in a normal, well, a bench oscilloscope. This is a normal oscilloscope, it's a USB oscilloscope, but on a bench oscilloscope you normally can do it even without the oscilloscope, with oscilloscope running. In here you have to have it stopped. You can also have a PC cache. Let me show you. That will create several images, and you can, when you stop again, you can then see what was the image. You can browse, export, and so on. Moving on the bottom, to the side of the stop and start and stop button, you have here the refresh rate. I will start by it can be this one, to sweep the channel 1, and let's slow this down, and you can see that the refresh rate is much slower right now. Yeah, this is the minimum and this is the maximum. I use it always in the maximum. I don't see any use for the minimum. We have here statistics. I will show you in a bit. Calibration. This one is custom curves. We already saw here the PWM usage. We also have digital filtering. I can show you right now. We have to set, you have here some examples, and you can set some values to do a filtering in the signal. And we have a reset button that will put everything to the defaults. Let's do auto. I believe that I have to, yeah, and turn this channel on also. Okay, so right now this is almost done. We have here the normal for the signal. We can do a peak-to-peak detection and a high res. If you activate the high res, you can see that the signal is with less squares. Look, take a look. Right now it has, yeah, less definition, and right now it's smoother, the lines. So in here, if you press in this zone, you will have the help. The domain of Loto instruments has changed, so the software is not updated yet, at least my version. You can press here to open the offline manual, and it will open a window with the PDF of the manual. Yeah, that's, well, that's some kind of help. Okay, so let's start by examining this zone. In here we have, and I will talk about the tabs in a moment. In this zone we have the time control. You can change it by dragging the wheel, but I prefer to click on the time. It's faster and it seems to work better. You can also use this for presets and choose the timestamp that you want, okay, the time division that you want. We have also the auto, and we have this kind of mode that show you, well, in a different way the signal. To be easier to work with the controls, you have also this knob here, this manual control that will allow you to have a better definition in the time that you select. In the you have also here a reset button that you can use to put it in the default resolution. So in the bottom or below this time control, you have the amplitude control of channel 1 and of channel 2. It's simple, it's the same way. You just press on the voltage that you want and it will change. You have also some fine adjustment here that you can do. You can control here if it's using AC or DC. The probe, if it's 1 time, 20 times, well, 100 times. Right now it's a cable, so I'm using 1 time. You can invert the signal, okay, and you can remove the baseline. The curious part is that if you take this, it will take the baseline from both channels. There you will notice there is some controls that are associated to a channel or to the other. We have also the ghost modes, as they call it. Normally this is called the persist. As you can see, it will persist the color. In here they call it ghost mode, but normally in the oscilloscopes it's referred as the persist, and you can have time to the drag and everything else. In this second channel you have something that is only proprietary of this channel, is the logic analyzer. The logic analyzer, when used, it will disable the second channel and will allow you only to use the logic analyzer. This device comes with 6 logic analyzer channels, and you can use also the probe for the 7th one, sorry. Yeah, that's it. It's simple. Let's take a look in these tabs on the right. The first one is the controls that we see. We have a second one that allow you to change the sample rate for 4 mega samples, 2.4 or 500k, and also the FIFO size. It's right now on 1 megabyte, but can go up to 250 megabytes. The third tab allows you to save your signal. Let me sweep again and let's start. It will save 50 frames, but this can be configured, and I will show you in a bit how it can be configured. When it stops, it shows this message. I will stop this, and you will have that what we saved here in the disk, and we can play back to see what happened. We can stop, yeah, and start again. To configure the frames, you just need to come here and change it to whatever you want. Okay, you can also set a path for the video, and yeah, that's it. So in terms of tabs in the time, that's what we have. On channel 1 or channel A, we have the trigger. Also, it's triggered. It's like a single trigger. Okay, we can have the trigger mode that is always triggering, or just disabled. Also external trigger. We have here also the configuration for differential probe. It's the model IDM01, and we can have custom probes. We have here the configuration for some of the probes they provide, but you can design your own and the configuration of your own. If you come here to the directory of the probes, we can open this. Let me just show you. Open with the notepads, and this is an XML file that you can configure to your own probe. And that's something they incentive you to do, to create your own probes, and that's cool. That's very cool. Okay, so moving on channel B, you have some different configurations. Since you have the logic analyzer, you also have a tab for selecting the channels for the logic analyzer, and you have the configuration also for a differential probe and also a custom probe. And that's it for this configuration. One cool thing that we have here, on the file menu we don't have anything special, but on statistics you have some stats that you can select. For example, peak to peak for channel 1, and we can also have the rise time, and I don't know, the fail time, and something like VRMS. Okay, if we go here on this chart and press it, you will have the values for for this kind of values that we selected. The peak to peak, the frequency, rise time, it's in here, and it will create a graph with the oscillation of those values that we selected to be mentioned in this graph. So this is pretty cool. It's a very nice information. I selected several values, but you can have only for one of them. I like this. And you can export this information in text file. So yeah, you can select here the seconds or milliseconds that will fulfill the graph. I will disable this now. We have here the calibration for the oscilloscope, the normal calibration. And we have the customer curves. It's something that I have not the time yet to test it. So there is a video on the Tau TV, that's the Loto Instruments channel, but I tell you to go see it because to be honest, I didn't have the time to test all of this. We already talked about the PWM, and we have also the digital filtering that I already show you. Right now it's the time to show you the top steps. We have this one that is the main one. After that you have the function of signal generator. I will talk about the signal generator in a moment, but you have also the input-output do-it-yourself, where you can have several pins that you can use for probe or for output as you wish, and you can configure that in here. And again, that's pretty cool. They give you this kind of control over the oscilloscope. And another tab is the protocol decoder. Yeah, you have a protocol decoder with 5 options. You can decode WART, PC, CAN, SPI, and LIN. And yeah, it's very nice for an oscilloscope of this price range to have it a protocol decoder. And you have also advanced functions, advanced measurement, and I love this. This has a problem. I cannot select all of them. For example, now I select the options I want, but if I want to disable all of them but not losing the options that I selected, like activate and deactivate this function, we don't have that. We have also a deep measurement that will record every values, and you can export everything. But I love this. This is awesome. This kind of information. It's big, it's visible, and well, I really love this information. But we now have a problem. If I want to disable all of this at the same time, I cannot. I have to go each window and close it one by one. And that is, well, that sucks. Because if I want to use this in a few moments again, I will have to select all of these values again, and that is, it's not user-friendly, to be honest. I really like this. The way they show the information, but it should have a global channel on and measure and shot channel 1, measure and shot channel 2 on and off, but I don't think this is a button here. No, it's just an indicator. So yeah, it's not perfect, but it's pretty cool, but it can be improved. So Mike, if you are listening, this is a suggestion of improvement, to turn this on and off all of it at the same time. The last one is well, I don't know what comp means, but I know what this does. And let's turn this on and press here the screenshot. Okay, so let's take a screenshot of our screen. And right now we will browse the screenshot we took, and we will be able to, let's grade this out to differentiate one and the other, and we'll be able to move the image. As you can see, we can move the image and place it. We can also zoom in and zoom out. As you can see, the image grabs the menu, and also the left column with the vertical values for voltage. I have a critique to do. This doesn't make sense to be saved. It should only save the signal, so we can align the signal with the one we have on the screen and compare it to have this kind of information, or the menu here. It doesn't make sense, really, none. So maybe you should correct this. I don't know. But yeah, it's a nice function. Other than this, this problem, it's a very nice function. You can use this to compare the signals and everything else. You can, yeah. So moving on. Right now, let's talk about something like I didn't show before, but you can move the signal, both signals, to be honest, just like you do on a bench oscilloscope. But right now I will show you the FFT. Let me modulate some signals. Yeah, we have modulation. The signal, we can also see the phase here, okay, on the FFT mode. And we have cursors, and one cool thing that we have here is we can see the signal in 3D. We can even add more or less lines of 3D, and we can change the perspective of the signal, more or less space. It's pretty cool to see, really. We have here also some information about channel 1, channel 2, the colors you can define, the kind of FFT that you want. Henning, for example, but rectangle, it's the normal one. Let's put this again into the... Okay, it works pretty well. I like it. You have several modes: Henning, Hamming in Blackman for FFT. And yeah, let's see what else we have here. Let's take this out. For the next one, I will stop the modulation. Give me just a second, and we will do something different. I will show you. Okay, we have the math functions, a plus b, a minus b, times b, and we have division, I believe, also. Yeah. So the last one is the... Let me take this out. Does it make sense? Last one we have, it's the XY mode. It's called here the AB XY. So for this one, I will just do a change here on my function generator, and here it is. It's already moving. It seems okay. Let's change the amplitude. Nah. Okay. It's pretty fast. I can speed this up even more. And yeah. I was trying to see if the persist mode works here, but it doesn't. So it seems okay. You can use it to print the 3D designs. I can modulate the signal, and we have a complete different figure. Let me just... Yeah. So as you can see, we have also XY mode, and it seems pretty fast. It's okay for me. Let me take this out, and what else I have here to show you? I think that we are okay. Just to wrap the things. No, okay, I still have to show you the function generator and the logical analyzer. Just to show you these tabs also, the advanced configuration, nothing special here, but you can configure the PC page count, cache count for, I showed you before, the cache, the configuration for the COM, internal COM, and multi-channel if you have more than one board, you can connect it. Yeah. So let's now test the signal generator. I will show you. Okay, let's take this out. We'll not need this anymore. And we will connect here the signal generator. Let me just disconnect this cable. And connect this one in here. I will activate the signal generator, and we have a square wave, sine wave. Okay, let's do auto just to adjust better. High res, yeah. As you can see here in the camera, I'm changing the amplitude of the signal, and right now I will change the offset, so it's pretty fast to respond. We have here yeah, an effect, and yeah, it's fast, it's pretty fast to respond. We have also the triangle and the square wave. What's going on here? Let me put this down. This one doesn't seem to be working. No, let's bring it. Okay. Let's make auto. Much better. Much better. And now we can change the amplitude. Yeah. And the offset. We have here also the frequency sweep, and yeah, it's scanning from 0 to 10,000. Okay, we don't need to wait for all of this. It's simple. We can go up to 30, I believe 30 megahertz. Let's just put this at 1 megahertz, 1 million. Set frequency. And we need to do a auto set. Yep. Not perfect signal, but still works. Yeah, it seems okay. Don't forget this with the signal generator, and the logic analyzer is something about 100 and well, I will leave the price on the bottom of the screen, so I don't give you wrong values. But yeah, it's much cheaper than a bench one, so you will have those three things in a few hundred euros or dollars. Yeah, that's it. Let's move on to the logic analyzer. Let's just take this out. Yep, it's out. And we have here the logic analyzer. For the logic analyzer, I will use my oscilloscope square wave generator. Okay, it's connected. We have here a setup. I don't know why. I tested before. I recorded before this video the Portuguese version, and I tested before. The only 3 probes working are these. It should have 6 working. So I don't know why, but I only have these probes working. Let me just disconnect this and go back to in here and activate. Okay, channel 1 off. So you have here, it's easy to measure. Let me just trigger. Opa. Okay, you can easily measure the signal. The signal that I'm using, it's only a square wave. It's not a coded signal like I2C or SPI or CAN or something else. But you can see how it works. As I told you, only 3 channels are working for me. Probably a problem in the cable or the connections inside, I don't know what, but only 3 channels work. But that's not my critique, because I know that something is wrong with my device. But the problem is the colors that you see in here are not the same that we see on the cable. So it will be quite confusing to use. For example, right now I disconnected the channel 1, I believe. Let me connect it again. Yeah, the channel 1, it's gray, the cable, but in here it's orange. So it's quite confusing, and that kind of stuff should be easier to work with, because after we don't know which cable belongs to which, and it's a recipe to disaster. Anyway, you have a logic analyzer, you have a decoder, protocol decoder that you can use it. So yeah, I think this is a very nice deal. I have this problem with the logic analyzer, but it was the only thing that it was not on spot. Everything else it is very accurate and works pretty well. The version of the oscilloscope that I have here is 30 megahertz, so I will connect it again to my function generator, only to see how it handles at the maximum. But I cannot use it to measure the rise time or something like that, because it doesn't have enough. It doesn't do a rise time below 1 nanosecond. That will be the ideal for that. But I already ordered some equipment, and I will do a video comparing this equipment with my Rigel, with the O1 that I have here, and also with the Handtech pretty soon. Right now I have a sine wave, 1 kHz. I will increase it to slowly until the 35 megahertz. Sorry, let me just start by changing this to megahertz. I want this in 1 megahertz. Okay, right now it's 1 megahertz. Let's do an auto. Nice. This is 1 megahertz, and let's start increasing the signal. Another auto. Yeah. Right now it's 20 megahertz up to 35 megahertz. So right now we have this at 35 megahertz. The sine wave, it's usable. It's not perfect, as you can see. The samples are not enough, but you can use this. You can use this. Let me just change this 1 volt to 1 volt. And no, 2 volts. It's the minimum. Yeah. Let's bring this down. You see a lot of edges because you don't have enough samples. But yeah, it is what it is. This is the signal at 35 megahertz, the maximum of the oscilloscope. Let's put this at 10 to see how it handles. Right now it's at 15, almost half. And this is 10 megahertz. Yeah, and 1 megahertz. Well, yeah, I have to say that I've seen worse, and it's not perfect, it isn't, but yeah, we can understand this as a sine wave. So yeah, it's not the best, but yeah, we can understand this as a sine wave. Okay, that's it. Okay, let's wrap this up. What can I say about this oscilloscope? Let's start by the price. The version that I have here, 35 megahertz bandwidth with 100 megasamples per second, costs about 133 euros. Something like $140, $45. And for that, you will have the oscilloscope, the function generator, and the logic analyzer. Don't forget that you have also decoding, protocol decoding in the software. And yeah, it's pretty good. For what you get, the price is pretty good. If you go to the 100 megahertz 1 gigasample per second oscilloscope, the same model but with higher speed and sampling, you will pay $197 euros, something like $220, $230. More or less, depending of the time of the year on AliExpress, if you have a sale running or whatever. That price is almost the same of the Handtech DSO 200, but it's a different product. You have a lot of functions in the software. For example, the FFT has a 3D printing of the bandwidth of the signal that is being analyzed, and you have a lot of functions in here. The second part of advantage of this is the workbench space. With this, you don't need a workbench space. You can put it here on the shelf and it will take almost no space to work. And yeah, if you are starting and want all the stuff for the bells and whistles in here, this is a good product. I like very much the parts that they want you to develop using the interface, the open source interface that they provide. You can create your own probes. They have documentation for that and incentivize you to create your own probes and to connect using the interface to the oscilloscope. They even have a do-it-yourself kit that costs 10 euros, $12, $30 to make. That you will assemble the kit and connect it, and you can expand the oscilloscope with that kit. The probes that they sell, for example, the current probe costs about 8 euros, $10, give or take. You have even isolated probe for high currents and everything else. The probes go between $10 and 10 euros and 15 euros, $60, and you have a very good one that is a probe that allow you to transform this oscilloscope in a spectrum analyzer. With some functions of a spectrum analyzer for 80 euros, that probe, and that is amazing, man. For that price you will have the functions of a spectrum analyzer with it, with the spectrum analyzer probes already included. So yeah, it's a different product. We have market for every kind of people. I think there is a very good market for this product. I like benchwork oscilloscopes, but I could use this also, to be honest. It's a very nice product. It impressed me. I like I love to do this review and work with it. The software needs some corrections and some improvements. The UI, it's not so user-friendly as it should be, but all the functions are there. And it's a matter of improving the software. That's the good part of this kind of products. The hardware is always the same. You just need to improve the software, and that's easy. Because it's Windows software, it's not an embedded software, it's not a firmware, and it's pretty simple to correct some of the problems that the software has. Overall, I think it is a good product. It's an accessible product, I think, and yeah, I'm pretty glad that they sent me this for review. As I told you in the beginning, I didn't pay for this, it was sent for review, but I'm glad they did it because it was a pleasure to review this equipment. So yeah, I think this is a nice product. That's my overall opinion. Okay, that's what I have for you today. And if this video in any way was useful to you, don't forget, give a big thumbs up. And why not subscribe the channel? And if you do, don't forget to hit that bell so you can be the first one to be notified every time I have a new video. I hope to see you in my next video. Stay safe. Bye.